Living in technology era, modern agriculture has significant role to protect their various crops to produce a high quality and rich nutrient. One of the methods used is by using pesticides to prevent pest disruption in that farm ecosystem. Pesticides refer to various chemical compounds, for example, herbicide, insecticide, nematicide, and fungicide. However, the amount of chemical and each type of chemical should be analyzed before it can be applied to the industry. So, this video will explain the chemical analysis of pesticide on vegetables.
So next, I will tell you guys about objective analysis. First is to determine which kind of pesticide with organophosphorus are in the plants. Also, to improve the sensitivity, specificity, and efficiency of the HPL technique. To identify organophosphorus pesticide in device vegetable matrix. And lastly is to throughout the testing process. Use quality control technique to guarantee the accuracy and dependability of the analytical data. The detail of the object will be present by other group mates.
Type of sampling method is random sampling, which is useful for ensuring that every vegetable has an equal chance of being included in the sample, thus avoiding bias. Chemicals that was used are antiacid, methanol, sodium chloride, acetonitrile, potassium permanganate, and distol. Procedure for random sampling. First, identify the batch of vegetables. Second, randomly select individual vegetables from different locations within the batch. Lastly, ensure that the sample size is sufficient to be representative. For example, 10 to 20 individual vegetables. The next one is tools and technique. For sampling tools, use clean, contamination-free tools like knife or scissors to cut the vegetables. For sample containers, store samples in clean or inert containers like glass jar or polyethylene bags to avoid contamination. Sampling collection procedure. The first one is from farmer's field. Sampling was carried out from July 2008 to last week of August 2008 from the farmer's field of 43 in southern Punjab. Normally, in the month of January, the temperature is low and the evaporation is low. The month of June and July are the hottest months in the study area. Rainfall occurs mostly in the months of July and August during the monsoon period. Sample of 3 vegetables which are okra, pumpkins, and eggplant that had extensively grown vegetables in the study area were collected. Information about farmers' aptitude, type of pesticide use, and agronomic practices adopted by farmers were also collected with the help of a well-structured questionnaire. The second one is supervised field. 3 summer vegetables which are okra, pumpkin, and eggplant were grown in the experimental field. Each vegetable was grown in a separate plot and each plot was separated. The vegetable received normal agronomic practices without spraying of pesticide. The sample was collected for a supervised field used for the spiking of
Preparation of sample was done in 6 steps, which is homogenizing, separating, bleaching, filtering, evaporating, and diluting. Firstly, the vegetable sample was grinded and then 50 grams of the grinded vegetables were mixed with 20 grams of mixture of sodium chloride and anhydrous sodium sulfate and 50 ml of ethyl acetate. And then, the mixture was shaken in a shaker at high speed for about 5 minutes and then the mixture was filtered. After that, the filtered mixture was transferred in a glass column containing 5 ml anhydrous sodium sulfate and 10 grams of activated charcoal. The mixture was vacuum filtered through a Wetman No. 6 filter paper. Next, the filtered solution was transferred into 250 ml round flask and then using a rotary evaporated at 55 degrees Celsius, the solution was evaporated and concentrated. Then, the concentration was filtered through a 0.45 micrometer filter membrane and the collected elute was concentrated just to dryness under a gentle stream of nitrogen gas. It was then redissolved in acetonitrile until the volume made up to 500 microliter for analyzing with high-performance liquid chromatography, or we call it HPLC.
We need to perform HPLC, which is higher performance liquid chromatography, on isopropyl system by using Shimadzu chromatograph. Before analyzing the sample of vegetable, this HPLC method was validated using chromatography parameters including recovery, reproducibility, and limits of detection. Thus, untreated sample of vegetable taken were spiked with selected pesticide for its recovery experiment. Next, to determine their fortification level, 5 replicates were analyzed by HPLC using UV detector. So, if the methods are efficient, this will validate statistics to distinguish the sustainable of pesticide with the vegetable by its recovery studies and fortification without pesticides.
Hi, back with me. So for this part, I want to explain about result. Based from our topic, 35 of the 100 vegetable samples tested positive for organophosphorus in Sedikides. The most contaminated vegetables was okra, which was followed by eggplant and pumpkin. From aspect pesticide residual level, per phenophos, 25% of sample okra, 17% of sample eggplant, and 5% sample of pumpkin. Next is trizophos, found in the sample of okra 40%, eggplant 11%, and pumpkin 2.5%. Other than that, chlorpyrifos detected in the sample of 90% okra, 22% eggplant, but not in the sample of the pumpkin. The third point is exceeding maximum residual limits, MRLs. The defined MRLs for some chemical have been made in a certain sample. For instance, profiniferous residues in the eggplant and okra, as well as chlorpyrifos residues in a certain sample of eggplant and okra above the lower levels. And lastly is agriculture practices. Higher reduced level was the result of the farmer frequently not sticking to recommended agricultural measures, such as the withholding period before harvesting, according to the study.
To sum up, the aim of this chemical analysis was to evaluate and determine the residue of 3 pesticides in vegetables belonging to organophosphate group. 35 out of 108 samples of vegetables examined were contaminated with pesticide residue. The vegetables with the highest pesticide residue is okra, followed by eggplants and lastly pumpkins. 8% of the samples also contain residue levels exceeding the maximum residue limits, or MRLs. These results highlight the need for more extensive and comprehensive monitoring programs that cover all vegetable types across various agroclimatic regions of the state to accurately assess the prevalence of pesticide residues. Future efforts should focus on integrating advanced technologies, fostering collaborations with research institutions, and promoting sustainable agricultural practices to ensure food safety and protect public health. These sustainable practices can help reduce the reliance on chemical pesticides, thereby minimizing residue levels in vegetables. In the future, more studies should be done to better identify the exact position of pesticides in vegetables.